Hey guys, welcome to Binados. In today's video, we are going to discuss about the set theory. See, it is one of the most important topic of discrete mathematics or for computer science. If you want to master discrete mathematics, then you must have a good command over the set theory. You will find whenever you will read any subject related to computer science, you will find that in somewhere or in some way each and everything is related to set. All the properties, all the formulas of the set is again and again using in computer science. So having a good command over the set will make you comfortable in your computer science subject. So let's now discuss about what is set. So basically set is a well defined collection of objects. Like if you have a collection of objects and you can define it in a way that it justify all the elements of that collection, then it is a set. Like if I have a set, like it is a set which has a name A. Like I have a set 2, 4, 6, 8 and 10. I have 5 elements 2, 4, 6, 8 and 10 and I have a set. Can I say it as a set? But before it I need to define it. Let's find out the definition of this particular collection. I'm not saying it set right now because I didn't define it. So first of all, what is the definition for this that is suitable for each and every element? If I will say that it is a collection of number, it is a set because it is a collection of number, then it is true because all are number, but it is not completely true because if I have a collection of number, if I have a set which is a collection of number, then where is 1 in this set? Where is 5 in this set? Because 1, 5 and all, there are a lot of numbers that are not available in this set. So this definition is not valid. Again, rethink about it, like uh, it is a collection of even number. Yes, maybe it is a collection of even number, but it is not the collection of all the even numbers. You define right if you say that it is a collection of even number, but it is not the collection of all the even numbers. So again we fail. uh, so I have one of the definition and you can check if it is right or no, if it is right or wrong. That it is a set because it is collection of even number which is less than or equal to. I give this definition to this set. Is it valid? Yes, it is valid. It means yes, this is a set. So in this way, if you have a collection of objects, firstly try to define it. If you are able to define it, then you can call it a set. Okay. Okay. Again, some terminologies are there for defining set. Like first is set is always denoted by capital letter. Like here, I give the name set A and I denoted it as a capital letter. Element of set is denoted by small letter, capital letter. Okay, and curly braces is used to define set. That is, if there is a collection and it is surrounded by curly braces, then you consider that we are talking about the set. Okay, and now some symbols that are more confusing to many students, like this is belongs to, not belongs to, subset, not subset. Like if a element present in a set, a element does not present in a set. Okay, subset, a set is subset of another set, and a set is not a subset of any other set. Okay, so like if we take an example, 1 2 3 4 5, I have a take an example, the set A which has 5 element 1 2 3 4 and 5, B which has 3 element 1 2 and 3. Now I will talk about whether one is belongs to A, then I will write it like this. Yes, one is belongs to A. One does not belongs to A or belongs to A. Yes, one is belongs to A or one is belongs to B. Okay, whether 4 belongs to B? No, 4 does not belongs to B. There is no 4 in the set B. Like whether B is a subset of A? Yes, because you can see that each and every element each and every element of B is also present in B. Whether A is a subset of B? No, because there are 4 and 5 which is present in A but does not present in B. Okay, so we got a definition of subset. Now a set let's consider its name as A. It's a set A whose element are whose all elements are also elements of another set B, then we can say A is a subset of B. It is denoted by A subset B. Okay, so this is the definition of subset. Now if I will take an example, like I have a set A, there is a collection A, E, I, O, U, and I have a set B as A, B, C. Now tell me whether A is a subset of B. No, because there is any element which is belong to one set but does not belong to another set. Like there's U which is the element of A but does not the element of B. So it means that A is not the subset of B. Or what about B subset A? It is also false because there is B and C which does not belongs to A. So in this way we can say that A does not a subset for B and B also does not subset for a A. Like we have another element A. Yes, it is a subset of B as well. It is a subset of A. Okay. Now let's move further and we will talk about like equal set. When we say that two sets are equal, so remember there is a very wonderful definition for equal set. Like if a set if a set A is subset of B and set B is subset of set A, then A equal to B. तब हम कह सकते हैं, then we can say that both sets are equal. Okay, so if we have a set, again example, because if you want to understand set theory, then it is obvious that you have to go through examples. After each and every topic you learn, you have to do some numerical problem, you go through some examples, only then you will be able to catch the taste of the set. Like A, B, C, and we have another set with the same element A, B, C. Now you can see that here A is a subset of B, B is a subset of A. So in this way, A is equal to B. Okay, so and this is the basic introduction of a set. I hope you enjoyed the video. If you like the video, then make sure you like the video, comment the video, share our video, and subscribe to Binary Dose. Thank you very much.